All right, hey, we're here at Emerging Languages Camp. Please introduce yourself.
Hi, I'm Joe Paymer. I'm a developer. I work on the FSharp compiler in Microsoft.
Excellent.
Hi, I'm Rich Hickey, and I work on Clojure.
Yes, and you've been on Channel 9. You're with Brian Beckman on an excellent conversation.
Yes, that was fun.
Absolutely. So refresh people's minds. What's Clojure again?
Clojure is a dynamic language. It's hosted on the JVM and CLR. It's a dialect of Lisp. It's functional, and it really is oriented towards allowing you to interact with the host. So it's really good for accessing Java and C# and .NET libraries.
Interesting. I want to come back to that in a second because of Sharp.
And it's also oriented towards concurrency. It has a good concurrency story. All the constructs have a good concurrency story. So.
Okay. Now, FSharp is essentially doing what he had just mentioned, that you have the, sort of a functional language that can interact with the CLR and other languages.
Yeah, FSharp is very deeply integrated with the CLR. It's a first-class .NET language through and through. All the types that we generate are .NET types. Our generics implementation is .NET generics. So we really pride ourselves on being a first-class language on .NET. It's a functional, statically typed language, type inference. The core of the language is heavily inspired by OCaml, but we've taken a lot of inspiration from C#, in our object system, Haskell, other functional programming language. So I think it's a very powerful tool for doing more exploratory, data-oriented programming on .NET, and it makes it really easy to sort of roll components that expressed in a way that best suits the solution for a certain target domain, and then you could integrate it with other .NET assemblies. So it makes component authoring pretty nice, and the tooling's pretty good too.
Cool. So one of the questions I would ask is, when you're targeting these sort of large runtimes that are statically typed, right? So this JVM, the CLR, the static type system is burnt right into the machine. Talk to me a little bit about some of the challenges that you've had using and creating a dynamically typed functional language with Clojure.
Actually, the story on both platforms, the CLR and the JVM, are good.
Okay.
Because they both have reflection capabilities. So as a dynamic language, you start off, if people want to do more of a duck typing, just call .foo and see what happens. You're able to do that because you can use reflection to do that. One of the things Clojure prides itself on is that all access to the host it's not wrapped at all. There are no wrapper classes created. There's no magic, Clojure object class that it has to wrap everything with. So access to the host is straight through. And in addition, Clojure supports type hints. So if you're doing something in an inner loop and you don't want the reflection overhead, you can provide a hint, and that hint will be used to generate a compiled call exactly the same as one you would make from C# or Java. And so once you do that, there's no performance hit at all for being dynamic there. Probably the biggest challenge being dynamic on those platforms is the fact that languages like Clojure have boxed number systems. They have arbitrary precision numbers, and they automatically grow. So doing that requires you to use boxed numbers by default. There are ways to get out of that in Clojure and start using primitives, but by default you're boxed, so that's a little bit of an overhead. Otherwise, I think the platforms are good for dynamic languages in general.
Interesting. So let's talk a little bit about, you mentioned here's a question for you. So when you're using a feature of FSharp which isn't available at the type level, operating against C# or maybe Clojure. Let's talk a little bit about, for example, the units of measure, right? There's no units of measure in C#. There's no units of measure in Clojure. How is that? Talk to me about how that works.
So for units of measure, that's more of a typing compile time issue. So it's more you're annotating floats and integers to detect typing errors at compile time. It plays into the static typing system. But for things like discriminated unions or closures, then that's a little bit different, because those are constructs that are more deeply mapped into sort of the functional style of programming, and maybe the representational semantics of the code that we generate might be a little bit different. So, or even unfamiliar from, say, if you're consuming an F# assembly from C#. So we have put a lot of effort into things like, for instance, discriminated unions to produce interfaces on discriminated union data types that, when consumed from C# have a more natural semantics from that regard. For example, if you have a discriminated union that would map well into an enumeration, that it gets generated as enumeration. I mean, that's the enumeration data type in there. And for closures, we have an interface F# func, which gets compiled down as the closure. So the type itself is exposed to another language as an F# func. So it's quite natural there as well.
Okay. So I mean, you guys have been here for a few days. What do you think of? What do you think of F#? And I'll put you on the spot. I mean, you're a language designer. I mean,
I think F# is very cool.
Yeah?
Yeah, I think it's very cool. I think I would prefer it over any other .NET language. I mean, coming out of Microsoft, I mean, I think it's fantastic that it's now an official thing. I mean, I really think that's a stunning thing that was done to make it a supported language, part of the product suite. So I like it. I'm impressed by a couple of things. One, how good the REPL is, how good that interactive story is actually quite good considering it's static. And I think the async work is also really interesting. So both of those things are neat.
Interesting. And you know, I'm going to ask you the same question, right? I mean,
I think Closure. Yeah, I think Closure is amazing.
Right.
If I had to, yeah, I mean, I think your runtime libraries are phenomenal. I mean, the work that you've done with persistent data structures is just great. The async program model is fantastic. I mean, I'm a big fan of Lisp style languages to begin with, so I mean, they would automatically draw me over to it. And even the performance that you're able to achieve on the JVM, I think, is great. Like, it's indistinguishable from Java in terms of those profiles for similar tasks. So I think it's a great implementation, a great language with phenomenal, really forward-thinking and just libraries that are really impressive. So.
Cool. I mean, one of the things that I was thinking about today, when you think about all the languages that there are, I mean, we learned a lot. When you look at the languages that we've learned over the past few days, a lot of them are very similar. I mean, there weren't 40 or 50 different, like, wow. But that sort of programming in languages in general, 60 years old, hasn't evolved that much. Lisp is pretty old, right? So let's talk a little bit about when you think about going further, how do you see engineers, let's get out of the language geek mind, really utilizing F# and Closure in, how does it make them more productive? As an engineer, you want to get things done, right?
Well, I mean, yeah, you want to get things done.
Let's talk about that.
So yeah, you want to get things done, but by things, I mean, there's a task at hand, right? So you want, we're basically tool makers. We want to make good tools to match jobs, that people are performing. And so for more declarative languages or functional languages like F# or Closure, I mean, if you're not just an engineer, but say a scientist or someone working with data, you want the semantics of the language to really, map the way you think, the way you approach a problem in a very kind of not pain-free, but in a very straightforward fashion. So functional languages are really great that way because you're always trying to express what you want to accomplish in terms of what you want to do, not how you want to do it. And then with these new, with platforms like the JVM or the CLR, the way that it really makes it possible to componentize your application, not just on a straight assembly basis, but also on a language basis. Like you could use Closure or F# to do maybe some of the more algorithmic heavy lifting, but when it comes time to do a UI, you could use the great tools that exist for Java or C# to sort of plug that stuff in there. So in terms of engineers, being able to use these languages or these new languages to do things, I think the platform is really important, and also the fact that these new languages are in a lot of ways enabling new modes of expression that might be more natural to an engineer just trying to get things done. Because to move from the whiteboard to the editor to write code is just a more straightforward mapping in some respects.
Interesting. And I guess another question I'd ask you, being the inventor of Closure, what were you thinking when you designed it? Who were you designing it for? Anyway?
I was designing it for myself. I think if you're not doing that, you're not an honest designer. Or you're doomed to failure. Okay. I was definitely designing it for myself. I have a lot of experience writing code, especially concurrent code that has to run 24/7 or on election night, in C++ and Java and C#. And doing that well is extremely hard, especially concurrent programs. And so I wanted to make that a lot easier. And I think programming can be substantially easier. And I think functional programming is a way to make more robust programs faster than any other method. And so I wanted to have a language that did that. I wanted more meta-programming facilities than I find in the traditional languages, so that's why I like the Lisp part. And I really wanted a language where immutability was the default, and to make that fast and idiomatic and easy. But I certainly think, there's this whole like getting things done, and there's getting something that sort of kind of works, and then there's getting something that actually works.
Yes.
And a functional programming language is going to let you get something that actually works done faster, in my opinion.
Now, I mean, of course, you have to explain that. Why is that your opinion?
Because any part of your program you can make functional. It's not really limited to functional languages. For instance, I worked on the National Exit Poll system, which is a C# system, which we write in a highly functional style. And we do that in self-defense because it's a highly concurrent system. It's full of algorithmic stuff, right? It's full of, all of these statistical models for doing projections and predictions. You want to do that well, and you need to have it be reproducible, and you can't have a lot of state. So the reason why functional programming in a functional style makes for a more robust program is because your logic is always local. If you look at a piece of code and you're trying to understand what it does, everything about what it does is right there. Okay? A piece of stateful code that's connected to a bunch of other stateful objects, if you want to understand what it does, well, you have to look all over the place. And fundamentally, that's the simplest story. There are lots of other things. If you're using immutable data and you share it with someone, you don't have to worry about that. Right? So that makes it easier to understand what your program does. It reduces the scope of worry because things are more local.
Okay. Now with F#, I mean, you guys aren't, I'm not going to use the term that actually upset Don when we used it about purity.
Right.
That was just Eric going on one of his tangents. But in some sense, you guys aren't necessarily immutable. I mean, so there's a way for you to be more like C# in F#.
Sure. I mean, so immutability is the default in F#. I mean, and that's what we want because, you want people to have an escape valve if necessary. Some programming tasks are better suited to, to have mutable data. I mean, we don't want to make life more difficult on programmers if we don't have to. But by making immutability the default, we're gently guiding programmers in the direction of not having mutable global state, componentization, things like that. So I think it's like a real boon for us that way. Just like it's possible in F#, but just like how in C++ you have to specify things as const, to kind of have that sort of flip on things. In F# you just have to specify it as mutable, and then automatically when you're looking over the code, it just can raise an alarm. Okay, well this is some mutable state right here, and there are still restrictions that we place on that as well. Like you can't wrap it in a closure, you can't transfer it out. It has to be local there as well. Cool. There are ways around that as well with reference cells and things like that. But for the most part, we really encourage the more functional, immutable way of doing things, unless that's not what you want.
Sure. Well, I mean, in some sense, with all due respect to Anders and stuff, F# really is a better C#. And the way I mean by that, and I can say this because I'm the idiot behind the camera, but I only mean by that because you have this wonderful power where you don't have to make C# look functional when you want to be functional, as you did perhaps in the exit poll. You can actually just program very simply a small amount of code to do something that would be kind of more too much ceremony in C#. That's what I mean. You can write a powerful .NET application, take advantage of the CLR, your base class libraries that come with it, and not have to have too much ceremony around your code.
Well, I mean, it really depends upon the design that you're trying to achieve there. It's like, so if you're a more functional design and you're not really thinking so much in terms of object-oriented types or componentization or being able to share those components with, other environments, other languages, then maybe something like F# would be a better choice because, everything is just right there at your fingertips. But something like C# though is, the goals are different.
Yes.
Like, you can program in in a C-sharp-like style in F-sharp, but it's going to be more painful than just doing things directly in C-sharp. Like if you're writing imperative code, you're going to want to use C-sharp because the hurdles aren't there, the intentionally placed hurdles aren't there. To have mutable states, to have those kinds of codizations. So
Totally.
and plus, just sort of the more we use or we emit .NET types through and through, but in terms of structural data types and things like that, there are certain semantic differences as well that you may be just wanting to express things in a more .NET CLR C# type fashion, which C# is and VB as well are excellent tools for that. So I think all three complement each other very nicely on on the CLR that way. I don't think any one is doing the job of the other in a better fashion. I think they all have sort of their domains that they excel in.
Sure. Fair enough, man. Good answer. That was a great answer. And certainly accurate. The way I said it perhaps didn't come out well, but at least it prompted you to answer a question like that. So that's nice. Now let's talk about real-world adoption of Clojure. Who's using it? Like what? I mean, last time I think we talked to you about a year ago now. What's going on with the language?
Tons are going on. I mean, there are many times as many people using it now than then. I mean, there's a mailing list that's just about up to 4,000 people on it. Nice. People are getting jobs, people are getting hired.
Wow.
People are forming startups. Those startups are getting bought. It's being used for flight delay prediction. It's being used in trading systems. It's being used in telecommunication systems.
Nice.
It's being used for all kinds of things. What's interesting and fun is it's being used for sort of the hard part of the problem, which is another typical domain for F# as well. It's kind of like you have an algorithmic component. You need to make a domain-specific language for your quant guys. These are the kind of applications for which Lisp has always excelled, and Clojure does as well. And you can do more lightweight things. People are doing websites, and those kinds of frameworks are coming up around Clojure. So all kinds of things.
Interesting. Now, why did you name it Clojure?
Why did I name it Clojure?
Yeah.
Well, it's a pun, obviously. It's a play on words. Originally, I think I wanted a word that had C, L, and J in it. C for C#, because the original version was written in Java and C# together. One file, then the other file. So it had C, L, and J. The J substitution gave me all three for Lisp, C# and Java. And then I, looked for the domain. It was empty, and I did a quick web search, and there were no hits. And what could be better?
Perfect.
Grabbed the domain, and it's been a great name.
It is a great name.
Yeah, it's really been great because when people search for it, all they find is stuff about the language. It's not ambiguous at all.
Cool. So, before we let you go, I mean, as the language designers, what's the hardest part of your sort of world? I mean, when you sit back and go, wow, I need to design this new language because I see these problems that aren't being solved in these. I mean, certainly there must be other languages out there that are like Clojure. I mean, it's a Lisp, as you mentioned before. But what do you do when you sit back and go, this is going to be unique because I'm going to just explain really quickly the process of your creativity in creating languages. It's really what I'm trying to get at.
Makes
sense.
I think first you should go go shopping, right? Because if you can find a language that does what you want, you should just use it, right? Or contribute to it and help it out.
Okay.
So for me, I wanted a dynamic language. I wanted a Lisp. I wanted a functional language that had an excellent interop story with one of the two major platforms, the CLR or the JVM. And I couldn't find all four of those things in one language. There were lists for the platforms, obviously plenty of dynamic languages. There were almost no functional languages. And most of the interop stories were not great. So that gave me a space that said, well, if I solve all four of those problems, there's an empty square or whatever in the multidimensional space. There's space for this new language, and it would satisfy what I wanted. And then you just have to get lucky. Other people who want what you want, who want to be in that space, and it happens to be the case that it seems like there are for Clojure.
Excellent. So is Clojure your favorite language?
Yes.
I mean, it's a fair question.
Yeah.
How about you? I mean, you write a lot of C++. or had to go through a lot of C++. You were talking about and cleaning up the compiler.
Well, yeah, we had. So originally the compiler was written in OCaml with some C++, and then when we joined DevDiv, you know, when FSharp was being productized, it was immediately the compiler was bootstrapped. So our compiler is completely FSharp code now. When I first joined the team, there was some C++ code that needed to be written, which was rewritten in FSharp, which was a nice exercise because, you know, you sort of, FSharp isn't really a systems programming language. I mean, you could do you could do anything you need to do in it. But, you know, different languages have their different strengths and focuses. So just having to kind of get through some of those tasks and to think in a systems programming way using a functional language like FSharp and sort of having to bend the compiler to do some of those things was an interesting exercise. And it also, you know, shored up a kind of, you know, we found a few bugs and was able to kind of shore up some of our support for things. Like we found a few com bugs and things like that to get things right. So it was an important exercise as well. Like I think one of our strengths as a language implementation right now is the fact that we're bootstrapped, because it is a great test of a language, you know, the expressiveness of a language to be able to kind of self-host and do that. And, you know, being in part of the ML family of languages, I mean, they're particularly well suited for implementing compilers. So we, you know, in some ways we had a little bit easier, but it's still been a nice exercise. So.
Excellent. And the Clojure compiler is written in
Java. And C#.
And C#. I mean, yep, when targeting
right,
CLI.
when it's the port, right.
Totally. One last question. There's a lot of excitement because FSharp is a first-class citizen, and I think that's great, and Rich had mentioned that's a wonderful thing. But the problem with that, one could argue, is that you're then locked into the release cycle of Visual Studio, right? And so you guys make some really interesting discoveries and anomalies. In other words, one could argue that perhaps FSharp may evolve faster than C# is, right? Because you're a newer language.
Yeah, we're not a part of the frame, you know, our runtime's not a part of the .NET framework.
Yeah.
You know, there's that. Then there's the fact that, I mean, you know, we're going to constantly continue to develop the design of language, to improve the language, to think of new things to do. And, but, you know, we also, you have to time things, you have to phase them. If we're dropping a new runtime every week, you know, it just makes life more difficult for our users. You want to give your users, the developers, time to really, you know, learn the language, absorb its features, start writing interesting code, give us feedback about what we could be doing better and things like that. So you know, the pace of innovation is important. The opportunities to do that kind of work is important, and you know, the fact that our runtime is kind of out there is sort of an interest, a nice way, and also the power pack that we have as well. I mean, the way that the language is designed is that you know, you can sugar over language aspects of language to produce operators and things like that. So we do have, you know, certain experimental operators in the FSharp power pack that people can go to CodePlex, see the source for, download, and experiment with. So you know, even with us being aligned with the whole Visual Studio release cycle, I think in some ways it's actually a benefit. So.
Cool. And again, I wasn't trying to create controversy.
Oh no,
absolutely.
absolutely.
I just, you know, it is another way to think about it.
Sure.
But it is cool. You're first class, right? You get all the great testing and all the great.
Yeah,
now, one other question would be, in terms of the CLR, were any changes necessary in the CLR to support you guys first class?
So, I mean, the CLR, I think, is really well designed from that standpoint. I mean, it really was, it wasn't, you know, the CLR isn't just a VM for C# or VB. It really is designed for multiple languages, different programming paradigms to execute on there. You know, because our language has a different sort of code generation profile than, say, C# or VB, you know, you're going to find rough edges or bugs, but, I mean, nothing that wasn't fixed, or we didn't really have any major asks of the CLR. I mean, I would encourage other language implementers, you know, to check it out. I think it's a good platform for that kind of work.
Common language runtime. Right on. So hey, thank you guys for your time.
Thanks a lot.
Thanks.
Rich, good luck. Nice
you.
to see. We'll see you again maybe next time.
Sure.
And we'll see how your language has evolved from last time. Great job,
Okay.
man. Glad to see it's doing well.
Take care.
You too.
Thank you so much.